Okay, so I said that this video we talked about finding the relative maxes and mins. I kind of lied. We won't actually find them. We'll talk about how to find them, but we won't actually get there until the video after this one. This one is specifically increasing and decreasing functions. This gives you all the prep work you need, though, to find the relative maxes and mins. So, you don't need to draw this. So this is 4, and this can be -2. Okay. So let's say that we're talking about where the picture was increasing and decreasing. So you are increasing when you have this upward trend. So you're increasing from, say, -infinity to -2, and then from 4 to infinity. You're decreasing everywhere else, which would be from -2 to 4, okay? There is a way that you can use calculus to do this without actually looking at a graph. You can use the function in calculus in order to figure out the increasing and decreasing functions, okay? So, what happens, what you need to remember is that you can use the first derivative to tell you the slope of the tangent line. And everywhere that the function is increasing, your tangent lines have something in common. Specifically, if you were to draw tangent lines, no matter where you hit them, these aren't great tangent lines, but pretend, all of your tangent lines will have a positive slope. Similarly, where your function is decreasing, not great, but your tangent lines will all have a negative slope. So that means that the derivative would be positive where your function is increasing and negative where your function is decreasing. And these switching spaces, where you switch from increasing to decreasing or decreasing to increasing, are your critical points, because that is where the derivative would be 0 or non-existent. So in terms of steps, okay, to figure out where the function is increasing or decreasing, first thing you have to do is you have to find the critical points. In case you've forgotten, that's where the first derivative is 0 or non-existent. Then you use the critical points to break your graph into intervals and you test a point from each interval in the first derivative. And you plug those points into the first derivative. At that point, one of 3 things will happen, but really one of 2 things should happen. If f prime of x is greater than 0, or it's positive, then f of x is increasing. If f prime of x is less than 0, then f of x is decreasing. If f prime of x equals 0, then f of x is constant. However, realistically, this would mean that the entire derivative was 0, which shouldn't happen. So if you find when you've plugged in that the first derivative is 0 at that spot, you probably missed a critical point. is more likely than that this happened. When it comes to finding the relative maxes and mins, which we won't do yet, but we will do eventually, is you need to know that a function will increase to a relative max and then decrease to a relative min, which again makes sense. So when you switch from positive to negative, those are your maxes. When you switch from negative to positive, those are going to be your mins. So now we're going to do 3 of these for practice. That'll be it. I'm going to determine the following are increasing or decreasing. All right, so step 1, you have to find the critical points. If you're trying to find the critical points, you have to take the first derivative. Not doing the quotient rule. So we found it. Yay. Now you have to see where it's 0, where it doesn't exist. So this is a rational function, so to see where it's 0, you set the top equal to 0. That's useless. To see where it doesn't exist, you want to set the bottom equal to 0. So then x is 0. So, and this is important, you will always have one more interval than you have critical points. So you have one critical point, which means you're going to have 2 intervals. So what you do is you make something called a sign chart. Sign chart will always have 3 parts. You have the interval, you test it, and it will tell you if the function is increasing or decreasing. So your function breaks at 0 because that is your critical point. So you've got 2 intervals. You have everything smaller than 0 and you have everything bigger than 0. So mathematically, everything smaller than 0 goes from negative infinity to 0. Then you pick it at 0 and go to positive infinity. Now you have to test it. When it comes to testing the function, you can do so in 2 different ways. You can manually pick a point in each of these intervals and plug them into the function, which is fine. And when it's a simple function, that's the way I tend to do it, just because it saves me time. Okay? So if you plug in, say, -1, -2, whatever, you don't actually care what the value is. You just care if it's positive or negative. So if you take a negative number to the 5th power, you have a negative divided by then a negative. That's going to be positive, so that means you're increasing. If you take anything from 0 to infinity, that's a positive number, so you've got a negative divided by a positive, that's negative. That'll be decreasing. Okay? So then what you need to do, because they specifically ask you to determine where the following is increasing and decreasing, you want to write it down. The sign chart, especially in AP Calculus, is never considered enough. You want to say, okay, so then I'm increasing from negative infinity to 0 and decreasing from 0 to infinity. Also for AP Calculus, they like for you to justify your answers for this. So again, the chart is never enough justification. You know that you're increasing here because f prime of x is greater than 0 on that interval. If you're ever asked to justify. Similarly, you know you're decreasing here because f prime of x is less than 0 on that interval. So that's one way to do it. Okay. The second way to do it, I'm going to talk about in the next example, simply because the derivative is uglier and not where I would want to necessarily mentally plug in if I had to, if I didn't. You could. But when there's an easier way to do the same thing, you might as well pick the easier way. So this is important. This problem has a square root in it. When you have a square root problem, the first thing you need to do is you need to set a domain, because these don't exist everywhere. Sometimes they do, but they don't always exist everywhere. So often it's necessary to set a domain. So let's see. When you have functions that are structured like this, it usually exists in one of two spots. So this function is going to break at -8 and 8, because that's where it's going to be 0. It's either going to exist on the outskirts or in the middle. So if you plugged in points from your two intervals, if you went with like 9 or -9, that's where it doesn't exist. So from -8 to 8 is where your function is going to happen. So that would be your domain. So at this point you want to find your critical points, but you're only worried about the ones that fall between -8 and 8. So you want to find your derivative. So then you've got, first derivative of second times -2x. So -2x plus second derivative of first would be 1. So then you're looking at -x squared over plus so same thing. I would go through and make common denominators so that you can have one chunk of a term. I feel like it'll make it easier. So then you're looking at -2x squared plus 64 over the square root of 64 minus x squared. So then you do two things. You want to see where it's 0, see where it doesn't exist. So to see where it's 0, it's a rational function. You want to set the top equal to 0. See where it doesn't exist, you set the bottom equal to 0. You don't need to include the square root, because same thing. First thing you do would be to square both sides, and then the square root disappears anyway. So this one is easier, so I'm going to start here. So then x is just plus or minus 8, but those are already the edges. We don't care so much. Here, subtract the 64, divide by 2, you've got x squared is 32, so then x is plus or minus the square root of 32, which you could break down if you wanted. I probably wouldn't bother, because it's not going to help me in any way, shape, or form. You want to make sure that they fall within your interval. Negative root 32 and positive root 32 both fall between -8 and 8, so that means I have two critical points. Two critical points means you're going to have 3 intervals. So you add an interval and test it and figure out if you're increasing or decreasing. So this one is different than the last one in that you don't start at negative infinity. Your domain starts at -8. You're going to start at -8. So you're going to go from -8. So between these, if you're following along the number line, first one that would show up would be negative root 32. And then you pick back up at negative root 32, and you would take it to positive root 32. Pick up at positive root 32, go to 8. Okay, so So this function, while it wouldn't be super terrible to plug in, it's kind of yucky. So if there's an easier way to do it, that's kind of nice. So what I do, if I'm in a hurry and trying to do this, is instead of plugging in, I would, with my calculator, graph the first derivative and look at it with your eyeballs. So what you care about, this is a deeply rough sketch of that, okay? What you care about is filling out this row of the chart. So you don't care if the picture is increasing or decreasing, you care about the sign of it. So you want to know if it's positive or negative. Because we know that here and here, those are the places where the first derivative is 0. So this is my negative root 32, and this is my positive root 32. So that means here, which is to the left of negative 32, which would be this interval, you're below the x-axis, so that means that it's negative, so that's decreasing. Even though the picture is increasing, no one cares. You want to know if you're above or below your x-axis, because that's your sign. That's all you're interested in. From negative root 32 to positive root 32, you're in here, that's above the axis, so that's positive. Here, you're going to be below the axis again, so that's negative. You can't just assume you're going to alternate. You do a lot, but not always. So then you're increasing here and decreasing there. And then same thing, because it asks you to determine where you're increasing and decreasing, you write it down. And those are your intervals. Last one. I erased the instructions. It's the same thing. Okay, so you're looking for where the function is increasing and decreasing. First thing you have to do is you have to take the first derivative so you can find your critical points. So, you've got bottom derivative of top minus top derivative of bottom over bottom squared. And then you have to clean it up. So then here you'll have 12x squared minus 6x minus 6x squared. So then you're looking at 6x squared minus 6x over 2x minus 1 squared. Fine. So then two things. You got to see root 0. See where it doesn't exist. Eventually you do this type of thing so much it almost feels like a reflex and you don't think so much about it. So it's a rational function. At C root 0, you want to set the top equal to 0. See where it doesn't exist, you want to set the bottom equal to 0. Again, you don't have to include the squared. You can if you want to, but then get rid of it immediately so it feels deeply pointless. Here you'll factor out your 6x. So then x is 0, and x is 1. Here you will solve for x. X is a half. So that means that you have 3 critical points, so you're going to end up with 4 intervals. So going along the number line, you're going to hit them one at a time. So you start at negative infinity. Smallest value is 0. Then you pick up at 0 and you go to a half. Pick up at a half. Go to 1. you pick up at 1, go out to infinity. Same thing. This is enough intervals that I personally don't want to test them all, so I would just graph it and look at it with my eyes. You know how we didn't use the calculator for the majority of chapter 2? You're going to want to make sure that you use your calculator for this chapter, because it saves time. Sure. So these are your 2 zeros, which means this is 0. That's 1, and half is somewhere in the middle. So if you're looking from negative infinity to 0, you're up here, which means you're positive. 0 to a half, half to 1, and 1 to infinity. Okay, because you're above, below, below, above. So then you're increasing, decreasing, decreasing, increasing. The reason that I like to do this particular example is you're increasing from negative infinity to 0 and from 1 to infinity. When it comes to talking about decreasing, you can't span the gap and say you're decreasing from 0 to 1, because you're technically not. At a half, you're not doing anything. So where the chart splits, you need to make sure that you split your intervals, even if they pick up at the exact same spot, okay? So not 0 to 1, 0 to a half, and half to 1, because nothing happens at half, okay? So then that is it.